So you are already familiar of this particular thing that is called SOP, or called sum of products. So if I have written a function like this, y is equal to a bar c plus a b bar c plus a b c bar plus a b c, then this particular form in which we are writing is called canonical form. This is called canonical form, and all the terms here are called minterms, are all called minterms, and it can be written as 0 1 1, 1 0 1, 1 1 0, 1 1 1, and this is called M3, M5, M6 plus M7. So this is the another way of writing the expression being given to you. And in some books, the other convention which is being used is like this: 3, 5, 6, and 7. So this particular form is called standard SOP. So here you can find the things that this is your canonical form. These are called minterms. This is called standard sum of products. So if we represent any term, then it can be in any of the possible formats. Either it can be in canonical form, or it can be in standard form. If it is not in standard form, then you are supposed to do that. So I hope this concept is clear to all of you. So I'm moving ahead now. So let's do a example so that you get a very good idea of the things being discussed with you. I am making a truth table. In truth table, I am putting the values, and on the basis of those values, you are supposed to make other things, which I will be discussing in the coming course of time. So A and B are inputs, Y is your output, and corresponding to that, you will have these set of input combinations which are being possible. So your output is 1 0 1 1. So it's a random thing. We have not done any sort of manipulations for that. It's a random thing. Just let you people know what we are actually doing. So if truth table is being given to you, the first thing you're supposed to do is fill the truth table. And after that, if I ask you people to write the canonical SOP or standard SOP, or we can say minimal SOP. Okay. So let's do the thing. So first we are interested in canonical SOP. So canonical SOP is your A bar B bar dot 1 plus A bar B dot 0 plus AB bar. Okay, so from truth table, you note down these values here and multiplied by the corresponding values. This is nothing but AB into Y. So substituting the values, so you end up with A bar B bar plus AB bar plus AB. Okay, so this is your canonical form. This is your canonical SOP. Now next, if I want this to be written in standard SOP, then how you're going to write it? So your standard SOP is sigma m, and here you can see this is 0, this is 2, and this is 3. So this is your 0, 2, and 3. So basically you are writing all the min terms. So min terms are those which can be set, those combinations which leads to high output are called min terms. Okay. And what about the minimal thing? So if you minimize it, you will get A plus B bar. So this is your minimal SOP. This is your minimal SOP. So now whatever we have revised is the entire case for your sum of products. Now I will be discussing the case for your product of sums. So we also call them max terms. So we will be discussing about them. POS are called product of sums. So here you can see that if you are being provided terms like this A plus B plus C and A plus B plus C bar, and it can be written as A bar plus B plus C. So this is called canonical POS. This is called canonical POS. And these terms are called max terms. So what are max terms? The terms for which your output is 0 are called max terms. So suppose we are now doing into this particular thing. So this is nothing but 0, 0, 0. This is 1, 1, 0, and this is 0, 1, 1. So what this actually is, so you can, if you look at this is nothing but A bar, B bar, C bar. And if you take the complement of this, so this becomes A double bar plus B double bar plus C double bar. So double complementing a variable. So this is 0, 0, 0, but actually this is complement of this. So this is this, so it is being written as this. So complementing it, this is M1 and this is M4. So these are the max terms. So suppose I ask you people that this is your min term and find out the corresponding max terms. So just complement it. And this is your max term. This is your max terms. Or in other words, we can say M5 bar is equal to M5. So min term is complement of max term, or max term is complement of min term, vice versa. So now this is your canonical form. This is your variable itself. So it becomes A plus B plus C dot 1. This is standard POS. Now next is to minimize this. So when you minimize it, you will get B plus AC, or it can be written as B plus A or B plus C. So this is minimal PO as product of sums. So this is minimal sum of products, and this is minimal product of sums. So this is how you can write down the various things related to your expression. So expression can be written in any of the forms in which it is being available. So that's all as far as this particular thing is being concerned. So now let's discuss about K-map in detail. So when we talk about K-map, so in the previous class, we have started discussing about K-map. So let's discuss about K-map in detail now. So first of all, K-map need to be drawn in this particular fashion. So if it is a 3 variable, then a total of 8 cells will be there. Okay, one thing I would like to share with you, that whenever you are writing it like this, then make sure you are actually looking forward in a manner that you are not making any sort of error. So suppose you are making it as this, then BC values will be 0, 0, 0, 1, and it is a gray code. So both the bits will not change simultaneously. So after 0, 1, it becomes 1, 1, and then 1, 0. So now from here onwards, how you are actually number them. So A, B, C. So this is A bar, B bar, C bar. So this is 0. Then A bar, B bar, C, this is 1. Then A bar, B, C, this becomes 3. Then 2. Then 4. Then 5. Then 6. Then 7. So this is the first way by which you can number them. Now, some of you might be interested in this, that instead of this kind of thing, you can have K-map in this particular fashion also. Yeah, that's equally well. You can have K-map in this particular fashion also. So here you can see we have done the necessary things. So this becomes AB and this becomes C. So here 0, 0, 0, 1, 1, 1, 1, 0, 0 and 1. So 0, 0, 0, ABC, this is 0, this is 1, and this is your 2, 0, 1, 0 is 2, then 0, 1, 1 is 3, then 4, 5, 6, and 7. So this is the other way of writing the things. But when you solve it, you will get the same answer. It's not the fact that you are writing in this particular fashion, you are bounded to get a different answer. No, that's not possible. You are always getting the same answer. Yeah, the things which you might get confused are, suppose you are having A, B, C, then you should know that this is MSB and this is LSB. So this is your most significant bit. This is your least significant bit. So if you treat here this as MSB and make ALSB, yeah, then you are going to make errors. Otherwise, there are no chances of making the errors if you know that A is MSB and C is LSB. Now, the first thing you have done is drawing the K map and numbering the cells. So we have numbered the cells. Now, suppose I have given you a standard format in which I have given like this 0, 1, 4, 5, 6, 7. So these things are being given to you. These are sum of products. And I ask you people to minimize it. Now, the one way which you already know is using Boolean algebra. That means you will write it in canonical form, A bar, B bar, C bar, plus A bar B C plus A B bar C bar plus A B bar C plus A B C bar plus A B and C. And then you can minimize it. Other way is K map, which I'm going to discuss now. So 0, then 1, then 4, then 5, then 6, and then 7. So in this way, you are going to fill all the values. So these are ones and rest of them are zeros. So you fill all the values being given to you in this particular cell. So here also you can fill them 0, 1. Okay, sorry, I'm using different thing. So 0, 1, 4, 5, 6, and 7. So here these are 0. So this is how you will actually fill that. Now coming to words. So before this, you are already aware of that. This is A bar, this is A. This is your B bar, C bar. This is your B bar, C. This is your BC. And this is your BC bar. Similarly, this is your C bar, this is your C. This is your A bar, B bar. This is your A bar, B. This is your AB. And this is your AB bar. That's all. Now, after this entire exercise, the next exercise, which is of importance, is to go for grouping. To go for grouping. So, what is the basis of grouping that I'm going to discuss now in K-map? So, first thing you look forward is maximum number of cells together. And it's not like that 5, 6, no. It's like there are 8 cells, so either 8 or 4 or 2. So in this fashion, they are going to be grouped together. So here you can see we are not having 8. So we will be grouping them in the group of 4. And why we are doing this entire exercise? We want all cells to be covered. All cells to be covered. Now these two ones are not covered. So it's not like that once covered may not be covered again. It's not like that. You can cover as many ones as possible, as number of times. But thing is, no repetition should be there. Okay. So now the next grouping is like this. Because what fundamentals say? That maximum number of groups should be there. Maximum number of groups should be there. So group is 4. Okay. So here also your grouping is 4 and we can group. It's like a world. जैसे आप दुनिया देखते हैं तो you can go to America by this way or this way because Earth is round. You can go from this particular direction and you take an entire circle around the Earth and reach the same point. So same is the K map. So you can map in this direction, in this direction, in this direction, in this direction. That's up to you. It does not have much effect or any effect on this. So grouping is like this, grouping of 4 and grouping of 4. So once you have grouped, then you are supposed to write the way in which you are actually grouping them. And you will write down the things which are constant. So here you can see, I will be using thicker thing and now yellow. So here you can see when you look at this here in this cell along this direction 0 to 1, that means there is change. So we cannot list it. Now when you look in this direction here, then B bar is constant, C bar is changing to C. So that means corresponding to this cell, we are going to write B bar. We are going to write B bar. Now coming towards this cell. So when this group is being listed, so here you can see the value is changing from B bar to B bar, B bar to B, and then B to B, C bar to C, C to C, and C bar. So all the values are changing. So we cannot list them. The only thing is we always write which are constant, which are constant. So here you can see this is constant. So A. So your grouping is B bar plus A. So this is your minimized expression. So this is your minimized expression or SOP. Similarly, here we will see this is the one group of 4 and this is the another group of 4. Okay. So here you can see if you look in this direction, your C is changing and your A is constant. So you will write down A. Now coming towards this group again, your C is changing. So you do not write that. And here this is A bar B bar and this is A B bar. So which is constant? B bar. So you will write it down as A B bar. So that means if you do in this way or this way, your minimized expression will be same. The only thing you should take care of is that you are sure that which is MSB or which is LSB. So I hope you get some idea about K-map. Now let's have some discussion on this so that we can get some awareness about what we are actually doing.